our channel Physics for Life, and today we're going to see electric charges and currents. This is the topic, and let's start. So you may be asking yourself, what is an electric charge? There is a simple definition, that it is the deficiency or excess of electrons of a body in a surface, which has charges Q, that is the physical property of the matter, measured in coulombs, that is represented with letter C, capital C, and the representative formula for the charges is the following, that is Q equals IT. The representative symbol of the charge Q and its measured units is coulombs. As I mentioned before, it's represented with the C, where 1 coulomb charge is equal to 6 times 10 to the 16 power. That's a lot. 18 power actually, sorry. And an electron, which is 1 coulomb, or you can represent it as this, 1, this is a 1 C, it's 1 coulomb. The amount of charge which can be moved as an ampere current from one point to another in 1 second of time equals to 1 coulomb. The force of attraction or repulsion between two charges or particles is placed of distance, or as the letter R in lowercase, and can be calculated with this formula, that is let me break it down for you. This is the force in newtons. This is the constant. K is always a constant, and the value of K is always 9 times 10 to the 9th power. Q1 is the first charge of the particle. Q2 is the second charge of the particle, and R, as I mentioned before, we're going to take it as the distance. So, now that we know what is an electric charge, what is an electric current, you may be asking yourself. It is the rate of flow that is generally in electrons. I'm going to erase here. That is generally a current, and is represented with this, with an Y. With an I. Sorry. What also can be measured in amperes, and that's it. And we have a formula, very nice formula. Q. This is a Q. R. Yes. Actually, it's a T because in R is in the Spanish. Okay, there are two types of electric currents. We're going to be describing an AC current, that is a flow of charge of electrons with the charging direction and magnitude, and the DC current, which is the flow of a current, the flow of a charge of electrons, which is in one direction with a constant magnitude. Now, we need to see what are the Ohm's laws. The Ohm's law is actually one. It states that the relationship between electric currents and potential differences says that the current flows through the most conductors is directly proportional to the voltage applied to it. Okay, so now that we know the basic definitions and formulas, now let's see an example where we can apply Ohm's law. So the example is with the conventional domestic fan. The fan that we always turn on when we have hot, when we're hot, and when we are thirsty or feeling sticky. We can control the speed of the fans in our homes by moving the regulator to FRO, F-R-O. And here the current flowing through the fan is controlled by the regular resistance through the regulator. A circular knob and the component can be rotated to achieve this variable, the resistance on the output terminals. For many specific values of the input, we can calculate the resistance, current, and thus power flowing through the Ohm's law. With the same, I'm gonna do here a little drawing that is going to be represented as the example that I am saying. I'm gonna erase here. So the formula we still needed, which is I B over R. Sorry, R and B. Yes. Okay, so now we're going to do the drawing. This is the initial change of the resistance. We're going to be drawing with black here. I'm going to continue. That's a lie. This is not the resistance. This is the start. This is the resistance of the fan. And then also continue here. And here is the voltage. Now it's a V. Mixing the arrows. And that's the current of the electrical fan. As I was saying, we can control the speed of the fans at our homes by moving the regulator and the probe. Here we can see that the current through the fan is controlled by the regular resistance through the regulator and the circular knob, and the component can be rotated to achieve a variable and the resistance of the output terminals. For any specific value of the input, we can calculate the resistance current, and thus this is going to follow through the Ohm's law. And to finish the video from today, let's see this problem. As shown in the below circuit, a supply voltage of 24 voltage is applied across the resistance of, okay, we have 24 voltage. And our resistance is 12. We got a resistance of 12. So, according to our formula, we are going to be dividing 12 over 24 over 12, sorry. My cameraman is looking at me up weird, so I'm getting a little tipsy. 12, and this gives us the beautiful response as 2. We got an 2 equals 2. Lie, that's a lie. That's not an A. The amperes equals 2. Sorry, yes. And thank you for today, and that's all. Have a nice day.